strange to be back virtually, but thank you so much for having me, and I'll get started. So this is who I am. I'm recognised by peers as one of the top 50 global women in technology, one of the top 100 data visionaries. I run my own company and I've been doing technical community work for a long time. I'm also been named as a top B2B influencer and a thought leader. So this session isn't going to be technical, it's more about strategy in business. There are some great technical sessions appearing today. I know that Priscilla Camp is talking about AI in Power BI. So I would recommend her session to you. So what I'd like to do, first of all, is try and explain a little bit about what we mean when we start to talk about artificial intelligence. We often hear that organisations want to implement AI as if it's an extension on a new house that they decide to build one day. So now they can start to think that they are going to start to implement artificial intelligence in order to use some buzzwords or potentially from the pressure of competition. So I'm just going to stop there for a moment because I want to see if I can add in subtitles actually. So I don't know if I can do that from here. I will try and see if I can add those in. Speaker notes, we don't want the captions. Oops. Sorry about this, I just realised that I forgot to put captions on. All right, here we are. That looks, hopefully you'll start to see some captions. Okay, so how can organisations get started with these technologies in order to make sure that they are really making great use of them? Well, first thing they need to do is understand their data. Now, I know with this audience that you're all excited about data, as I am. Sometimes, however, it's harder for organisations to grapple with their data. For example, they may not always know what data the organisation gathers. They may also struggle to create data stories. And what is a data story? Well, it's identifying what people, processes and specific technology the company is utilising. I spent time as an enterprise architect for one organisation, and I sent round an email to everybody to ask them how many data visualisation tools were they using in the organisation. And I gave people a deadline of a week. The answer I got back when I counted them all up was that people were using 29 separate data visualization tools. Nobody mentioned Excel because they hadn't seen it as a data visualization tool. So in summary, they were using a total of 30 different data visualization tools. Now, artificial intelligence is only as good as the data which it receives. So if it receives data that's originally biased, then we know that we are going to struggle with that. So some of the AI success strategy is about understanding your data and doing the boring tasks that we all should be doing, all the data housekeeping, such as conducting a data audit regularly. Let's face it, who really does that? However, professional organisations should have data dictionaries and business glossaries. Also, it's crucial to have an understanding of the technology and how it stores the data. Is it structured data, for example, or is it unstructured? So all of this in one place. So AI can start to be a big job. But if you already have excellent data practices, then you're already partly on the way. So executives are sorting out and understanding that artificial intelligence can produce value to their organizations. The way it can do that depends how much they are going to let artificial intelligence do in the organization. You could have a starting point where you simply use artificial intelligence to simplify and automate a process that is already in place and which customers do not already see. And you could move along that trajectory from very simple processes that customers do not see, right through to customer-facing artificial intelligence solutions. So there is a progression that can be had. So let's have a look at some examples. Now here's an example where Uber are using Microsoft Cognitive Services to help riders feel safer. They're identifying and verifying artificial intelligence, drivers before they actually appear. So the idea here is that artificial intelligence can also be improved and improve processes to make people feel safer. It can make people feel that a bit threatened sometimes, as if AI is taking our jobs. I do believe that artificial intelligence will have an impact on people's jobs. When we look back at the advent of the internet, there was a great fear that the internet would steal people's jobs. It did not do that, but what it did do was change people's jobs fundamentally. And I think artificial intelligence will do the same thing. Now we have something here called Amara's Law. Roy Amara was an American futurist, and he said that we tend to overestimate the effect of a technology in the short run, and we underestimate the impact in the long run. And you can see a visualization here on the right-hand side of how that might look. So it's the same with artificial intelligence. People get concerned. They also have huge expectations, followed by the trough of disillusionment. And then eventually, people start to absorb the technology as part of their processes, and that's when people start to become productive with it. So it's also interesting to have a digital feedback loop. When we implement technology, it's very easy for people to buy technology, but not really think about whether or not it solves the true problems, which can be more about people and process. The best customers implementations are the ones which are customer focused. We have so many great ideas which we could use artificial intelligence for. But ultimately, artificial intelligence does not guarantee sales. If we offer a solution which nobody wants, then that's not going to help anybody. I did see recently that one of the organizations, actually there was a questionnaire on Reddit, believe it or not. And it was really interesting because somebody on Reddit simply asked, how do I get more people to look at my website? I don't really understand how SEO works. Search engine optimization, obviously. So the thing is that if you are not using artificial intelligence that solves a problem, the organization is in danger of becoming irrelevant. For example, in the UK, one of the supermarkets called Sainsbury's announced it would no longer sell CDs or DVDs. Now, only 5 years ago, CDs represented more than half of all music sales. Now, physically recorded music is less than 20% of the 1.5 billion sold in the past year. And 20% of that actually is now vinyl, not CDs. So the CD is no longer relevant. Most of us get our music digitally, and we don't even own it. We just rent it from the likes of Spotify. So on Reddit, Google's guru on SEO is called John Mueller. A website owner had complained on Reddit they'd lost all their traffic bit by bit over the 6 years. And all of a sudden, the person who invented SEO at Google jumped on. And the questioner had wanted to know if they could reinstate their web traffic by getting an SEO expert to fix the site. Now, the questioner on Reddit probably did not think that the top man on SEO within Google would provide them an answer. But that's exactly what John Mueller did. Mueller said that sometimes SEO cannot help at all. Hang on a minute, the top SEO person at Google is actually saying that SEO might not always work. Surely that must be fake news. Mueller, however, told the questioner that sometimes you just have to accept that nobody wants what you're offering. The Google guru said that many businesses provided just a few years ago were already outdated in the fast-paced online world. And this is one of the problems that happens with AI. Technology is moving at such a rate that you can't guarantee that your solution will be relevant. There may be a process of attrition. So many organizations consider that AI is an important topic. However, it's a tool like any other. This was taken from a study done by Microsoft. So sometimes organizations feel that they are running the Red Queen's race. You've probably read the book Alice in Wonderland and perhaps Through the Looking Glass. In the book called Through the Looking Glass, there's a part where Alice is running under the tree. She's not moving, she's running really fast, but she's just staying in the same place. And the Red Queen tells her, if you want to get somewhere else, then you have to run at least twice as fast as that. So it's the same when we start to think about artificial intelligence and our data. Organizations are already struggling with their technology and their data, and that has to be in place for AI to be successful. I sometimes hear that the DBA will become irrelevant. I don't believe that, not for a single minute. Companies' data is more crucial than ever, and DBAs are the guardians of that data. They're the gatekeepers. So we need to make sure the data is protected. Moving it to the cloud is just simply another way of saying that we're going to use Microsoft Data Center. It really is such a great place to be at the moment. But we can't become complacent. We need to go outside of the comfort zone in order to grow. And we need to think how we can look horizontally across the business to elicit the support of key stakeholders. That will help us to get a good understanding of what the customer needs and also what they need as well. Everyone can understand the potential for artificial intelligence, but they also have to be part of that story as well. You can't simply just tell customers what they want. So here's a statement from Ericsson. The challenge is that artificial intelligence will be available in many different places. So how do we start to manage all of that artificial intelligence? It's not always in one place or in one function. It's all over the place, like our data. So people are investing heavily in artificial intelligence. You can see here some of the AI transactions, a lot happening in France, Denmark and Germany. So there's so many investments happening at the moment. It's important to think about how that money is spent wisely. And the most important thing to consider is how we can use AI in order to support and help our customers. It's not always about the who or the what, it's about the why. If your story is compelling enough, customers will come to you because you are solving a problem. So why are you using it? It's not just a buzzword for organisations to consider. So here's a checklist of things to consider when we are considering whether or not to use artificial intelligence. One good way to think about it is I call it in terms of a number of C's. I do this to try and make it easier for companies to understand. We can start to think about how we can use artificial intelligence to raise the bottom line by thinking about our customers, our competition, how we can capitalise on opportunities, how we can create something new. We can think about AI and how it reduces our costs. We can also think about how it reduces our challenges as well. How can we use it to meet our challenges? We can also help it to calculate and make predictions based on the data. And we can also use the cognitive aspects of it, such as the cognitive services that Microsoft offer. So how do we conceptualize artificial intelligence? The best tool for AI is listening and empathy. We have to understand our team members, our customers, partners and suppliers in order to conceptualize how we can smooth out our processes and provide better services, products and solutions for customers using artificial intelligence. So we'll focus first of all on how we can gather information using AI. Now, most likely you're already using deep learning already. If you have conducted a Google or a Bing search by image, then Google Photographs can search your photographs based on the image content. So if you're using that, you're using a technology called deep learning. Now, deep learning is sometimes used badly by marketing people. It refers to a very specific version of artificial intelligence. It's a subset. We can use neural networks chained together in order to provide results. The mathematics behind it is extremely complex because the neural networks themselves are not always transparent in how they achieve those calculations. But if you're using Google Photos, for example, or doing a Google search or a Bing search, you're already using this technology. It's not going away anywhere. Object recognition is a difficult area of artificial intelligence. For decades, researchers have puzzled over how to make a computer see, computer vision, and how computers can recognize objects. And it's something that research going on for decades by people such as David Marr in the United Kingdom, and also William Gibson, who was a well-known researcher in the 50s. He was a pilot actually for the US Air Force. And although Gibson worked in the 50s and 60s, his theories have really helped us to visualize and understand how computers might see vision as well. So we've also got, we've already got Google's RankBrain. That's helping to return your Google web searches to you. So that's using artificial intelligence as well. Now it's also using a tool called Parse McParseface. That's helping us to understand language better. So Google and Microsoft's Bing are using a range of algorithms that use artificial intelligence, and you're already using these every single day. AI is part of our lives. And we can use these in order to gather information in order to support us. Many of us are knowledge workers, and that means it becomes crucial for us to be able to galvanize huge amounts of data and information very quickly. Another way that we can gather information using artificial intelligence is using speech recognition. Speech recognition is in our phones, it's in our game consoles, it's in our smartwatches and our smart devices. It's even automating our homes. For example, I have a kettle which is speech enabled. It connects to my Alexa, and I also have a Hoover. I have one of the robot Hoovers which links up to Alexa, and I tell it to go and hoover. So we're already using speech recognition all the time. It's become so much more popular now because speech recognition itself has increased in accuracy. In fact, you can see it displayed on the screen right now. So deep learning is really a way of hooking up neural networks together, and it already has many achievements. Speech recognition itself relies on data. Speech varies in speed, for example, and it can be very hard to align audio. If anyone has used any video making tools, you know that audio is often very difficult to deal with. So we use the original sound wave, and we use that. It uses spaced out sampling in order to try and decipher the data from the speech. To do that, we use the Nyquist theorem. It breaks up complex sound waves into more simple sound waves, and it does that using a Fourier transform. So that gives us a data representation of speed. It also has to recognise speech against a backdrop of voice and noise. For example, bad quality microphones, background noise, reverb and echo, and even accent variations like mine, all combine to make speech recognition a difficult topic. But you can use speech recognition today in order to help support your customers. You may find a project internally where this could be really useful for you, and you could do that using technology such as Microsoft Cognitive Services. If you're a developer using .NET, a data scientist could work with you. They will produce the algorithms, they'll work with those behind the scenes. And as a .NET developer, all you need to do is consume the web service using a REST API, and then you could publish and receive data from that. It really means that you can make your applications much more interesting. Speech recognition requires high compute power. So using tools like Microsoft's Azure can provide the high compute power in order for you to make speech recognition happen in your organization. So the process of training the technology behind the scenes is iterative. These are using deep neural networks. It's quite an iterative process, and Microsoft have already done that for you by offering services such as Microsoft Speech Recognition Services. Now, the latency of the training loop is really the rate limiting step that gates the progress. The models themselves of speech recognition can be very large. They can contain billions of connections. And Microsoft trains those in thousands of hours of data. And that means that the training of those speech recognition models will take a lot of computation. But it's all a design process between the business and the technologists. You can incrementally introduce speech recognition and then introduce it as you get more training data, and it will become more successful. We're using speech recognition in order to interface with computers all the time. It's also been used for translating languages. You may already be using it in Skype, for example. The overall goal is that we are enabling ubiquitous, natural speech interfaces, and your business and your company can already use these algorithms available to you. So we've got plenty of speech recognition possibilities as well. So we can use plenty of speech recognition possibilities to try and think about different ways that might help serve your customers better. Even translation might mean that you can start to open up to new global parts of the globe. So speech application has impact in search as well. There are plenty of other players. We have Google, we've got Siri, Apple, and we've got Microsoft's Cortana. And you may already have an Echo and Google Home already in place already. I know I certainly do. So speech recognition really touches on the Turing test. Now we get different flavors of artificial intelligence. Normally in business, we are focusing on narrow artificial intelligence, where AI is very good at one thing, very good only at one thing, and it's not something that is considered very general. Now, the Turing test touches on a different type of artificial intelligence. It's more aimed at the artificial intelligence that is more inspired by perception of AI in Hollywood. You've probably seen films such as I, Robot, or even Terminator, where you were using artificial intelligence, usually for good or for bad, but these AI robots, or AIs, if you'd like to call them that, have got very good contextual knowledge. Now, the Turing test is all about trying to see if a robot or an AI can fool somebody into thinking that it's human. So the Turing test has been around since the mid-1940s. It was postulated by Alan Turing, hence the name. I have a real interest in it because my great uncle used to work with Alan Turing, actually. He was also working at Bletchley Park, where Alan Turing was based. So this is a personal connection for me. So it means that we can explore what language means because it's so contextual as well. But this is where it's really good to have your business glossary in place and your data dictionary. Your organisation will have developed its own internal language for understanding data. And sometimes the only way to really understand the data is to really get to a common consensus of what those concepts actually mean. We need to make things more simple. We need to think about how we can reduce everything down to the simple. We're constantly creating new worlds and new models of the world. So these models all work together to create machine scale data and get it down to human scale data. Because life is not simple and we shouldn't expect it to be. So how can we make sense of all the data? So there's an interest and a resurgence in the field of narrow and general artificial intelligence. We're trying to make the machine scale data down to human scale. Companies such as Google, Microsoft and Facebook are all coming to the AI party. Because the thing is, the future of technology and the future of communication is all about the network. So networks are so important. They're complex, they're changing and they adapt. And they're the emerging language of the digital era. Networks mean we focus not just on the data but the connections. We focus on the nature of our relationships and the intensity of that information. We're thinking about chaos theory, and chaos is the state between order and disorder as we move from one stage to another. So we're never in our comfort zones. Instead of looking at individuals, we're focusing on them all, and we're thinking about complexity theory, relationships and patterns, and creating systems that are complex and adapt to our environments. AI itself is not a new field, but it has this resurgence because people are recognizing the power of the patterns in the data, and that comes from an understanding of the network. We can also think about how we have to look at the bigger picture and what perspective is this going, what impact will this have on people if we automate so much? What humans bring is that humans work so well in noisy, complex environments, and we do that so well in order to get the signal. If you take the human brain, it doesn't always know which features are the most important ones. Instead, it works out which features are the most important ones, and then it settles on an appropriate result. The process is stopped and it can always restart again, because as humans, that's something we're very good at. So that means that artificial intelligence can learn a lot from imitating human learning. Where humans are so good is we are creative and we have the ability to work in complex environments, and we use abstraction to build models of the world. It's not a linear process, but we can use artificial intelligence to make the most of our humanness and most of our design. So we can think about how deep learning brings its own technology as well. So what we have here is a number of terms that we sometimes might come across when we're thinking about how we approach data. So data science itself normally focuses more on the statistics. It's not necessary, but it's useful to know some basic terminology so we can understand the architecture, strengths and weaknesses. So a scalar is just a single number. A vector is a list of numbers identified by the scalar. A matrix is a 2D array of numbers, so that each element is identified by 2 indices instead of just 1. In maths, we tend to denote those by uppercase variable names in bold. And a tensor is an array with more than one axis. So when we think about neural networks, sometimes you might see these called artificial neural networks, since they are referred to by an acronym, ANN. Basically, it's a way of processing information. It's inspired by the way that biology creates nervous systems. So these are inspired by the brain, and we tend to move around back and forth when we are considering how the data flows from one place to the other. So here we are just making the point here that we can use artificial intelligence to create all of these apps. But fundamentally, without good data, AI is nothing. I'm pleased to see that there's a lot of research going into making AI more successful with smaller amounts of data. The research is still going on, but it's taking time in order to do that. Okay, so how do we get to be successful? You can help your company because you are data experts, and you can be a key part of trying to help the company to evolve, adapt and succeed using the Internet of Things and artificial intelligence to stay at the front of the competition and to win the Red Queen's race and to keep moving faster than ever before. There are issues, complications and benefits that the future of artificial intelligence could bring to us and our companies. However, there are some quick wins to help you to get started. First thing to do is to be unapologetic about starting small. Using technology such as Microsoft Cognitive Services can help you to get started rather than building lots of technology. It's the usual roll your own versus buy off the shelf kind of argument. That sort of argument's a bit tired, to be honest, so I'm not going to go into it here. The basic concept is if you want to get started, starting with small achievable chunks is a good thing to do. Eventually, later down the line, you might find that the standard off-the-shelf technologies are not meeting your needs. But then that's a decision that you can take in a more agile way, and you can do that in the future. Getting started and starting well begun is half done. Now, when you start any data projects, never mind just AI, you want to think about the right artificial intelligence capabilities, and that will equip you to meet key business challenges and create value. So what do I mean by that? Well, I really mean that different departments across the organisation will probably have similar problems, such as dirty data, a lack of understanding of the data, consensus around the data, and you've probably got a lot of technical debt and data debt hanging around. When you do these projects, you can probably be more successful at getting buy-in for those projects and stakeholder support for them if you can show that you are solving a problem that's horizontally across the business. You can also define a roadmap of initiatives. If your data is not clean, for example, then you should consider doing a review to understand the path of least resistance. So sometimes people get very stuck on buying technology, and that's great, but you have to make sure that the technology is actually meeting a need. I often see people that have shoehorned projects in place using technology which is not the right technology for what it needs. So it's good to have a beauty parade of the technologies in place before you get started. So defining a roadmap of initiatives really can help you to point in the right direction as a team. You might find there will be lots of disconnects between people in the organisation because people are not pointing in the right direction. So there will often be nuances, but you can always take a very flexible and agile approach as well. But again, a roadmap is more likely to help you to get support for your overall initiative. Now, you should also expect to adapt. You should adapt as the new business opportunities and advancements appear. So one recommendation is that you stay on top of the industry news. Read blog posts by Google, Microsoft, Facebook, LinkedIn, all these companies that are using artificial intelligence. You should expect to adapt, and don't be the company that's still selling compact discs when everyone else is consuming their data over Spotify. Sometimes we have to move with the times, but humans don't like change. We don't like to be changed, and that's sometimes the hardest thing. I know when I'm spearheading these projects, the change management is the hardest thing that I tend to do. So just a quick summary, think about how you can use artificial intelligence to better serve your customers. Your competition should be looking at what you're doing, but you should also review what they are doing as well. You can also think about costs. How can you reduce costs using artificial intelligence? How you can create and capitalise on opportunities. So there's quite interesting ways that you can serve your customers. You could use chatbots, for example, in order to help you to interact with your customers better. You can also have a think about whether you are definitely meeting a customer need or not. Like the example of John Mueller yesterday, talking on Reddit, your products might not be required anymore, and sometimes you have to have a rethink about what you are doing. You could use artificial intelligence to write the best copy in the world, but if nobody wants what you want and what you're offering, then they're not going to hit your website in the first place. So there's a chain of command really, sometimes in organisations where the CEO might dictate a certain path and everyone has to follow that. But the key idea here is that a crucial skill in any data project is empathy, understanding your customers, suppliers, partners, and team members. Because if you don't do that and you don't do it well, then you are probably going to have to watch your competition and take that forward from there. So if you're building a product, for example, and that product is available as part of another service, your customers may already be using that service, so that a product becomes your competition by default. And are you really going to build something which has really got enough impetus for the customer to buy your product as well as what they're already using. You tend to find they'll stick with what they've got and they'll just make it work for them because humans are incredibly adaptable. We can also think about reducing our costs. One of my customers is using artificial intelligence to help them to transcribe handwritten forms. It saves them a whole lot of time and effort. And the humans are still there, they're still in their jobs, but what the humans are doing is correcting the artificial intelligence when it hasn't done a good job. So it has changed people's jobs, but it's not got rid of them. It's just making the process faster overall. You should also think about creating. That does require a good understanding of the customers and also the industry as well. So you should expect to adapt all the time as new business opportunities and advancements start to appear. And you can think about capitalize and optimize as well. Optimize your processes. It's sometimes easier for businesses to buy new technology than have a look at their processes. But if the process is bad, they're simply going to use new technology in a bad way as well. So that means we can really think about exploiting the next wave of disruptive analytical technologies and techniques and make things easier for your team members as well. There's plenty of great tools out there. So to get started, I often use this diagram. It says data science on it. It actually belongs to Microsoft. I use this for artificial intelligence as well. And the key point at the top is the business understanding. I don't see many people talking about this or looking at this, but I suggest that this is a really nice way to try and conceptualize to business people what's happening, when and why. Use this as a benchmark for explaining to people what's happening. You'll find that it makes it easier for people to understand, and it will make things easier for you to explain as well. Because what we're doing here is focusing on the business understanding, data a huge part of that obviously, then we can model, then we can deploy. So we are looking at things like AI ops, ML ops, there's plenty of ops out there, ops is a buzzword. But all you're trying to do is solve the last mile problem of analytics and artificial intelligence, which is to make that productionized so that you start to generate business value. And that could be reducing costs, selling more because you're pleasing customers more. It could be capitalizing on an opportunity, so you sell more. So there's all sorts of reasons that you want to deploy and you want to get things to production. So you could use things like Azure DevOps for that. If you're not sure on which model to choose if you're doing data science, you can use technology that's already available in Microsoft. Using automated ML is one way of trying to choose the best model to fit your data. What that will do is it will take samples of your data and it will throw those samples at maybe 100 or so different algorithms. And then it will create a model based on your data. So if you don't have any data scientists, this might help you to get to a good start, or it could help your existing data scientists to become more productive by producing models more quickly that they can then refine. So we're not replacing the data people, we're just making things a bit easier for them. So the way that works is it's going to take some data and it's going to throw that through a pipeline. It will train and evaluate the model against the data, and then it will give you the results, and then it will keep iterating. It will do that in parallel as well. That's what it does in Azure Machine Learning for Python SDK. And it works its way through this sequence of modeling, and the automated ML sits in this part. And what we're trying to do, just as a quick summary, is trying to make our processes better, help people by imbuing computers and technology with thinking that's inspired by humans. So we think about the general version of artificial intelligence, which is about marketing usually, and then the reality, which is at the moment, AI tends to be better used when it's used in more narrow settings. But we should also remember that data is always first. All of these artificial intelligence technologies are amazing, but we always hear about how organizations want to implement AI as if it's a new build on a new house, something like that. But we need to organize and understand our data. We need to understand better the structure of our data, and we need to understand how should that data be measured. That means identifying the best statistical models that fit our data. So it's important to have a good understanding of stats and data science in order to be really good at AI. I know they make things easier for you, but this will make it easier for you to be right when you're using AI. You can't assume the numbers are correct. It can also help you to identify if there's any bias in the data. Sometimes people simplify things by looking at one axis and then moving on to another axis and then another one. And actually it just doesn't work like that. We have to start off with that multidimensional approach, having done a good set of descriptive statistics in order to understand the data. That will help us to choose the right tests so that we can validate the results better. In context, particularly when we look at bias in data, is so important. There is that temptation to simplify. But when people simplify, particularly when it's about people, they can start to become, to draw some really erroneous conclusions. And if people don't understand statistics, they're frightened to ask for qualification or verification because they don't want to appear like an idiot, even though that's not true. They don't want to appear sort of self-conscious about it. So we tend to have processes that we consider. So we want to think about the ability of how humans understand data. We can use that to identify certain basic visual properties. We can also think about our parallel processing by our low-level visual system to help us to understand data and have patterns jump out at us. Often we're looking at pre-attentive properties of the visual system, and we're using data visualization to help us to understand better. So we've got visual building blocks, and this is very low level in our perceptual systems. But what we want to do is go from the building blocks to finding patterns in the data that are useful in helping support us through our understanding of the data. I don't believe in the term data literacy. I think it's one of these awful terms that makes people sound as if they are data illiterate. I prefer data fluency. Our visual systems are built so that we have a good understanding of the world, and we can create these this understanding based on building blocks. We already have these visual building blocks as part of our conceptual apparatus. We have this as part of our perceptual systems. So data literacy in a way is a false term because we already have good data literacy. It's built into the way our brains process data. We just need fluency in how we can understand the data better. Because when we start to use these visual building blocks, we can try to make our data and results easier and better to understand. We can try and simplify things, and it's our jobs in order to translate the data to make it easier for people to understand. What we can't do is talk about data literacy and AI literacy, making out that people are illiterate in some way. That's really demeaning and diminishing to the audience. So what we should do instead is try to find ways and means to make our message more clear in the data and be able to explain how we got those results. That would also help us to identify any bias in the data that's been introduced. For example, by simplifying down to one axis rather than thinking about the data in a more holistic way. There's plenty of different ways that we can visualize our data. and we do that based on the type and the category of data. So we need a good understanding. We don't want to get things mixed up. Say, for example, you do a taste test, and that taste test is between 1 to 5 or something. Your 5 might be different from my 5. So sometimes all we can do is rank the data or have it as a nominal label, but we can't really order it because of individual variation. We can also skew people's perception of the data by adding in colour and data points like this. We have to make sure that we are accurately looking for patterns in the data, and that will help our artificial intelligence to become more successful. So if you want to make data more clear for other people, what you can do is consider that we are using some guidelines here. Use plenty of white space. Think about the data represented in the page rather than using data and using too much ink to represent very little data. Chart junk can often mean distracting people from the message of the data by adding in more in the chart that needs to be there. And context, like I mentioned earlier, is really important. We can add in titles and questions to make things more clear. And what this does is it allows us to help people to visually integrate the data with the patterns in the data, and then start to test and trust the results that artificial intelligence is producing. When people see it, they can understand it better. Otherwise, they are not allowed to be able to integrate that data. Cognitive integration gives us a much deeper understanding of what the data looks like. And by using cognitive integration, we want to help people to get to a good point where they really truly have been facilitated to understand that data. So we can help people to understand what AI is doing. We can look at the summary down to zooming and filtering on the data, then down to the detail. All of that will help support us when we are trying to explain the data to other people, and it's anchored in such a way that people can start to understand it better. Okay, so one term I just wanted to mention again, because I think people get very confused over that, is neural networks. They're inspired by human brains, and they are really trying to build up the maths between the input and the output. And they can do that by building in layers between each of those input and output points. So often I hear people say things like they want a neural network, and what they mean is they want artificial intelligence. So I just want to point out that a neural network is a very specific type of maths, and it's not equivalent to artificial intelligence, even though sometimes it comes across that it might be. People use the terms interchangeably, which is not great. And this is what they tend to look like. We've got an input layer, got an output layer at the right hand side, and then we've got hidden layers between the input and the output. And these hidden layers are the points where the maths really starts to become important, really helps to kick in. It really kicks in at this point because it's trying to work out the weightings between the input and the output in order to get the results. So that's how that works, really. We can also think about deep learning and big data. A key benefit of deep learning in particular is it gives you the ability to analyse massive amounts of unsupervised data as well as supervised. It makes it a great tool for doing big data analytics, because in reality, a lot of data is raw, it's unlabelled, and it's not categorised. Deep learning helps us to address important problems in big data analytics, such as discovering complex patterns or doing data discovery from massive volumes of data. So there are challenges that could be introduced as we start to look at streaming data, highly dimensional data, and how those models can scale as well. And that's where cloud computing starts to come in, because it will allow us to scale with those models. Big data is starting to go away as a buzzword because companies are starting to realise it's just data. So there are moves in artificial intelligence academic research to help us to work out how much data people actually need in order to be successful. And why is it different? There's so much data out there to interpret now. Text, images, video, sound, such as myself talking and that appearing as a transcript below. So with that, I am nearly 4 minutes left before the break. I wondered if anyone has any questions. I'll just go back onto Teams. But I wanted just to finish by saying a huge thank you for attending. I know it's not been a technical session, but when we talk about business intelligence in particular, there has to be a good business understanding in order to really make the most of what you're doing. So hopefully that gives you some ideas about change management and the adoption of artificial intelligence in your organisations. And with that, I'm going to hand back to Ray, and I will stop sharing my screen just in case anybody has got any questions.
Well, thank you very much, Jen. That was wonderful. I'm glad that you mentioned the fact that the captioning on there was an example of AI, and while it had it pretty well, it did make some mistakes. So yes. I think that was a very interesting way to do things. So meanwhile, let me come back here.
Oh, that's a lovely photo.